Okay, Geo honors. We're moving on to hyperbolas here. We spent a bunch of time looking at ellipses. We saw hyperbolas when they were centered at the origin. We're now going to just look at hyperbolas that are not centered there. They're going to be very similar to how we did ellipses not centered at the origin, so I feel pretty good about us cranking through this pretty quickly. There's going to be a few subtle things we need to watch out for, but other than that, I think you guys will handle this pretty well. All right, so going back to hyperbolas, do you remember the standard equation of a hyperbola centered at the origin? There were two of them, right? There was a horizontal and then a vertical. So the horizontal was x squared, oh boy, x squared over a squared minus y squared over b squared equals 1. This is your horizontal. Okay, and remember that a always came first. Okay, a always came first. In ellipses, right, a was always the bigger value. In hyperbolas, a always comes first. The way we'd tell the difference between a vertical and a horizontal was that the y squared would come first. So it'd be y squared minus a squared, y squared over a squared minus x squared over b squared. That equals 1. That would be your vertical ellipse, or vertical hyperbola, sorry. So those are the two centered at the origin. Now you can probably guess ones that are not centered at the origin are going to take a similar shape in terms of what we did for ellipses. So x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, that's your vertical, or excuse me, your horizontal. And then for your vertical, as you might guess, it's just the y coming first. So y minus k squared over a squared minus x minus h squared over b squared equals 1. Again, I repeat, the a squared always comes first. So that's one of the differences between ellipses and hyperbolas. We also have that minus sign in between them. Okay? So let's talk about the things we know, okay, about hyperbolas and what remains the same. So let's just kind of run through the things here. So the center, right, it's going to be at h, k, or opposite of h, opposite of k, however you want to think about it. The a value, right, a is still going to be not equals, sorry, a value, how do I say this? Still is the vertex, but we're just going to count the distance a away from the center, right? So let me just write that. A units away from center, but it's still going to be the key to your vertex, A, right? And B is still is covertex. Okay. Same thing as above. It's going to be b units away. Now remember, the b value, the covertex, actually isn't on the graph, but I'll show you in a minute how we use b to help us graph those asymptotes. Okay. C, okay, if you remember in hyperbolas, c was equal to, and that's where you can find the foci, was a squared plus b squared. That remains unchanged, which is great. C equals root a squared plus b squared. The asymptotes do, however, change a little. And let's just get a little color in here. Let's go with blue. Okay, the asymptotes do change. Not by a lot, but they do change a little bit. If you remember, it was y plus or minus b over ax if it was horizontal, and y equals plus or minus a over bx if it was vertical. It's going to be a little bit different. Our equation for the vertical or the slant asymptotes are just going to be y minus k equals plus or minus b over a x minus h. So this is basically in slope intercept, or excuse me, point slope form. That's going to be if it's horizontal. So notice it's still b over a. Okay, but now we have to account for the center. That's your horizontal. And then as you can guess, okay, it's y minus k equals plus or minus a over b times x minus h if it's vertical. Okay, and we'll come back to that in a minute when we start graphing. And then your eccentricity is still going to be c over a. Okay, so again, pretty similar. Probably the biggest change is going to be your asymptote. So just be careful with that. But I'll show you how we account for that in a minute. So we have a few problems here. I really just want to walk through one because I think if we walk through one, the rest are going to be piece of cake for you. So I'm looking here. Why don't we do C together? Because C is going to be a little bit trickier because it's not in standard form. So maybe we do one of the harder ones together, and that way when you do one of the easier ones on your own, it seems like a piece of cake, which I hope it is. All right, so let's work through C. And the first thing we want to do in C, since it's not in standard form, is to put it into standard form. So let's do this. Let's do x squared minus, I'm going to take out the 9. I'm left with the y squared plus 4y. And I'm going to add 4. Okay. And then on the other side, I added the 72 that was on the left side. That is a horrible 7. Let me fix that. I'm embarrassed by that. 72, and then we're going to add, not adding 4. We're actually subtracting a number here because it's minus 9 times 4. We're actually going to be subtracting 36 because it's minus 9. We're subtracting that number on the left side in reality, right? So if I rewrite this, I'm just left with x squared, okay, minus 9, stop this, minus 9 times y plus, my hand keeps hitting it, minus 9y plus 2 squared equals 36. We're going to divide each side by 36, and we get x squared over 36 minus, oh my god, y plus 2 squared over 4 equals 1. This, as we know, would be horizontal. Okay, so x squared over 36 minus y plus 2 squared over 4 equals 1. So let's start listing out what we know. We know the center. Center is going to be at 0, 2. Okay. A is going to be 6. B is going to be 2. C is going to be equal to root 36 plus 4, which equals root 40, which equals 2 root 10. My math's correct. Okay. So my vertices, all right, so my vertices are going to be 6 units, since this is horizontal, 6 units to the right and 6 units to the left of the center. And I'm actually going to start plotting this. So 0, 2, right there is my center. 6 units to the right would bring me to 6, 2. 6 units to the left would bring me to negative 6, 2. So I will write those in addition to plotting them because you can never give too much information. Your covertices, okay, and I'm actually going to do this, let's say in blue, because it's really not part of the graph, but you're going to see why I plot it and why it's helpful. So my covertices are going to be 2 units above and 2 units below the center. So that's going to bring me to 0, 0. And 0, 4. Again, I did them in a different color. You don't have to do it in a different color, but you'll see why that's going to be helpful in a minute. And if you remember when we did hyperbolas last time, we said you could actually create a box between your vertices and covertices. And I wasn't a huge fan of it when it was at the center, but you're going to see why it's helpful now in a minute. So what I want you to do is, using a dotted line, is make a box, okay, that captures, or a rectangle that captures your vertices and covertices. So you can see the dotted box there in blue. We'll come back to that in a second. Your foci, okay, your foci are going to be on the major axis, so it's going to be horizontal, and it's going to be 0, plus or minus the c value, which is 2 root 10, comma 2. Okay, so those are going to be outside the hyperbola. Root 40 is somewhere between 6 and 7, right? So if we were to plot these somewhere between 6 and 7, I'm going to do in a different color again. Let me just underline this in red to show you it's in red. It's going to be a little bit more between 6 and 7. So it's going to be somewhere there and somewhere there. Okay. Again, it's not technically part of the graph. There's just these points that the graph is equal distance away from, or the sum of their difference is an equal distance among all points. All right, I've got that. And then the equation of the asymptotes, which I'm going to do in blue. The asymptotes, if you remember, this is a horizontal graph. So it's going to be y minus the center value, which would be y minus 2, equals plus or minus b over a. So b over a is 2 over 6, or 1 over 3. And then x minus 0, you could have just written it as x. I did x minus 0 just to remind you that you do need to put the x coordinate of the center in there. But you do not need to do the x minus 0. You can just do plus or minus 1/3 x. Now, what you could do is put that into slope-intercept form and try to graph both of them, which you could do. Or, and this is why I think the box is easier, if you remember that we said that the asymptotes run through the corners of each of the boxes you drew, or you draw, that is enough. So what I'm going to do is just to draw a dotted line that goes through the center, right? Goes through each of the corners of that box. And those are going to actually be the graph of my asymptotes. If you were to actually change them into slope-intercept form and try to graph them, you would get that same line. Right? So if you remember that your asymptotes go through the corners of each of the box, it makes it really easy to plot them. So I think when your asymptotes are not at the center, that's the easiest way. And you can do it in all forms, whether it's at the center or not, whatever you like better. But I like using the box when it's not at the center. So those asymptotes are going through the corners of the box. Now the last thing left is just to draw my graph. So I'm going to do that now. Come on. Remember that the graph has to stay inside those asymptotes. Okay, so it's kind of these sidewards mini parabolas. There's one of them. Oops, it's not supposed to be hitting the slant asymptote there, hitting that asymptote, although it looks like it is. It should be contained in between. Okay, so that's all you need to do. A little bit of work. I think you guys can handle it. If we look up to B and A, right, they're already in standard form, so there's not much to do other than find the parts of the graph that you need to know and to plot. Just a word of warning, D, okay, pretty similar to C. I think you'll be able to handle it. There is a fraction as a part of the center, so just be careful there. E is going to be a little bit tricky. So if you get something on E and you're like, wait a second, what's that? Keep in mind it's designed that way. Give it your best shot. In an effort to speed things up in our next class, I'm actually going to post the solutions to this. So try working it through the rest of class now. And if you need to finish it up for homework, finish it up for homework. And then check your answers. Again, I'm curious as to what you think about E. It's going to be a little bit different than what we've seen. I'm not going to give it away, but just so you know that something's going to come up. Okay? So good luck with that. Come to class with questions on Thursday, and I'll talk to you guys then.